Hi, this is Swati, and in today's video, we will see the chapter Understanding Quadrilaterals of Class 8th. Yes, in this chapter, we will have curves, what are polygons, and about the polygons, we will learn in depth what are the types, classification, angle sum property, and everything. And at the last, quadrilaterals and its properties, very important. Now, let's get started. First, what is a curve? A figure traced out on a plane surface. Plane surface is, let us take an example, the whiteboard that you see, it's a plane surface. With the help of sharp pencil without lifting it is called a curve. So you can do anything without lifting it. So this is a curve. I am not lifting. So this is a curve. Similarly, this is another curve. These are all curves. I am not lifting the pencil and it is on the plane surface. Now, what is open curve? A curve that does not end at the starting point is called an open curve. So here by the name itself, we understand open means it is not closed. It is open at one part, right? Now here my starting point is this, whereas my ending point is this, so both of them are not same. Starting point is this, I'm drawing like this, but I'm ending it at here. Again, these are not same. So these are all open curve where they do not meet, the starting and ending points are different. Now next up we have is closed curve, a curve that begins and ends at the same point. It is just opposite to open curve. Now here let me just draw this figure. I'm drawing this figure. So where I'm ending, ending at the starting point. So when my starting and the ending point is same, then it is known as the closed curve, else it is open curve. Now what is this simple closed curve? A closed curve which does not intersect itself. So here you can see this is closed, all these are closed curve. But what about simple closed curve? Which does not intersect, but here if you see in this one, these curves are intersecting at a point, which means it is not a simple closed curve. Rest all of them are simple closed curve. I hope this curve is clear. Curve is basically you are just drawing something with the pencil on a plane surface without lifting the pencil, that is it. And closed curve is where your starting and the ending point are same, whereas open curve is where your starting point and ending point are different, both are not meeting. Simple closed curve is which do not intersect, the curves do not intersect. Now next up is polygons, very important. What is a polygon? See, poly means many and gun means gone, or gun means sides or angles. So polygons is basically associative with many sides or many angles. Obviously when it has many sides it will have many angles as well. Now let us see the definition. The simple closed curves which are made up of line segments only. So it is a closed curve. Simple closed curve means these curves do not intersect at any point. And they are only made up of line segments. Here we can see these are all polygons. See, they are made up of line segments and it is closed as well. Do not intersect. So these are all polygons. So they are made up of sides. They are made up of angles. So now let us see what are the types of polygons. Now, here we know that triangle, three-sided figure is a triangle. This is also a polygon. So, polygon is any closed curve. Triangle is a polygon. Similarly, quadrilateral is having four sides. Four-sided figure. Any four-sided figure is a quadrilateral, be it rectangle, square, parallelogram, rhombus, everything is known as a quadrilateral. Next is pentagon, five-sided. So here you can see 1, 2, 3, 4, 5. These are five-sided, known as pentagon. Hexagon, hexa means 6. Heptagon, hepta means seven-sided figure is known as heptagon. Octagon means eight-sided, oct means 8. Hept means 7. You can just remember pent means 5, and 3, 4 you already know it. Now next up is you have two types of polygon, convex polygon and concave polygon. Convex polygon is each angle is less than 180. That means in convex all the angles will be less than 180. So here these are some example of convex polygon. So these four angles are definitely less than 180, we can clearly see. Similarly, these four are less than 180. So all these angles are less than 180. But on the other side, when I talk about concave, at least one angle is more than 180. At least one angle. It can be two angles as well, but one angle you will definitely find greater than 180. Now let us see this example. Now this is definitely less than 180. This is less than 180. This is less than 180. But what about this fourth angle? This angle, if you clearly see, this is more than 180. So that is why this becomes concave. Similarly, in this, all these angles are less than 180, but what about this angle? This angle looks more than 180. Again, this is concave polygon. So convex is less than 180, concave is greater than 180. Now moving on, regular and irregular polygons. So it is very easy. Regular polygon is a polygon having all sides and all angles equal. So regular, the name itself suggests all sides, all angles are equal. For example, equilateral triangle, we know equilateral triangle, all sides are equal. Square, all sides are equal. So these are all regular polygon. Whereas irregular is just opposite of it, which are not regular. That means the sides are not equal, the angles are not equal. For example, rectangle. As we know, rectangle, all the sides are not equal, isn't it? Only the opposite sides are equal. All the angles are not equal. So that is why regular, all sides are equal. So see, this is regular polygon and these are irregular polygons. In irregular polygons, you can take up isosceles, scalene. These are quadrilateral. So this is pentagon, this is regular. All these sides are same. So if this one side is 5 centimeter, remaining all sides are going to be 5 centimeter. So this is the difference between regular and irregular polygons. Now next up, okay, let us see what we have learned till now. Let us match this following. Firstly, we have learned all convex, all the angles are less than 180. Concave, at least one angle is greater than 180, isn't it? And simple closed curve where they do not intersect. All right, now next here we see that here we see all are simple closed curve, isn't it? Because they do not intersect. We can see that all are simple closed curve. They are not intersecting at any point. Whereas convex means all the angles should be less than 180 degrees. So here if I see this angle is greater than 180 degrees, isn't it? So this one becomes concave. Whereas here if I see all of them are less than 180, so this becomes convex. I hope this is clear. And this is not a polygon. Why is this not a polygon? So if this is not a polygon, it cannot be convex or concave, because polygons are only made up of line segments and no curves. But here if I see these two are line segment, but this is a curve. So this is not a polygon. I hope this is clear. This is not a polygon. All right. Now, angle sum property, very important. Angle sum property, you are having two types, interior and exterior. As we know, interior, inside, it belongs to all the inside angles, sum of all interior angles. Whereas exterior angles means the outside angles, the angles that are outside the polygon. So you can see this denotation 1, 2, 3, 4, 5. These are all exterior angles. Now, how do we find the angle sum property? Sum of all the interior angles or sum of all the exterior angles? Now, this is most important slide of polygons. So here you will find all the formulas and it's very easy to remember. I will explain it to you. Now, sum of interior angles of a regular, I'm only talking about regular polygon. Keep that in mind. Sum of interior angles of a regular polygon is given by n minus 2 into 180 degrees, where n is the number of sides. I am going to explain one example in each. Now, sum of interior angles of any polygon. Now, okay, let me take a pentagon. Okay, pentagon, this is pentagon, which means n is 5. All right, I'm not taking triangle, quadrilateral, because we know in triangle sum of all the angles is 180 and in quadrilateral sum of all the angles is 360. I'll show it to you how. Now let me take pentagon. In pentagon you have 5 angles, right? But I'm not sure that sum of all these 5 interior angles is equal to how much. So for that we have this formula, which is n minus 2, n is 5, into 180. So n minus 2, 5 minus 2 is 3 into 180, which is 540 degrees. So in a pentagon, sum of all the interior angles is always 540 degrees. Now coming to next one, sum of exterior angle is always 360. So whenever you have any polygon, be it 10 sided, 8 sided, 7 sided, whatever it is, sum of all the exterior angles is always 360. Be it you have 10 exterior angles or 5 exterior angles, the sum is always going to be 360. Now next one, each exterior angle, very easy to remember. Each exterior angle, since I need to find each, I'm just going to divide it by number of sides, n. And each interior angle, how do I find each interior angle is 180 degrees minus each exterior angle. Why? Because suppose I have this pentagon, if I extend, now this is my exterior angle, correct? This is the exterior angle of a pentagon. Now the relation between interior and exterior angle is always linear pair. Now here I can see that a linear pair is forming. So if I know my interior angle, I mean each exterior angle, I can easily find each interior angle by 180 minus each exterior angle. So you just have these 4 formulas in polygons and you're good to go with the polygon chapter. It is very easy. Just these 4 formulas you need to know. I hope this is clear. Now, so we know that what is sum of all interior angles, sum of all exterior angles, and how to find each interior angle, each exterior angle. This is it. You are done with half of the chapter. The next half of this chapter is quadrilaterals. Now in this we are going to see what are different kinds of quadrilaterals, what are its properties and all of it. Now let us see quadrilateral. Quad means 4. Lateral means sides. So four-sided figure is a quadrilateral. Here we can see any closed polygon, because as we know quadrilateral is a polygon with 4 sides, 4 angles and 4 vertices are known as quadrilateral. It could be a regular or irregular polygon. So regular polygon is basically square, yes, and irregular polygon is rectangle. So all of them are quadrilateral. So it has 4 sides. These are the 4 sides, these are the 4 angles, and these are the 4 vertices. Now let us learn about each quadrilateral in detail. Now here firstly angle sum property of a quadrilateral. So as we just learned that sum of all exterior angles is always equal to 360 degrees. Not just for quadrilateral, any polygon you take, sum of all exterior angle is always 360 degrees. And sum of all interior angles is also 360 degrees. How? Let us just find out using the polygon formula we just learned. So now here, as we know, n is equal to 4 because four-sided figure. Now to find sum of all interior angles, what is the formula? N minus 2 into 180 degrees. So 4 minus 2 into 180, 2 into 180, which is equal to 360 degrees. So this is how you find sum of all interior angles of any polygon by using this formula. Right? Now let us see all the kinds of quadrilaterals in detail and let's see their properties. You will be having most of the questions from this part. First is trapezium. It is a irregular polygon. If a quadrilateral has one pair of parallel sides, then it is a trapezium. So this trapezium has only one pair parallel. So this is parallel to this side. So WZ is parallel to XY. Hence it is a trapezium. So in trapezium, only one pair is parallel. No other property you have. Clear? Now you also have something called isosceles trapezium. I've not written it, but I'll just tell you about it. Isosceles. Isosceles, when you hear about isosceles, we know that two sides are equal, right? Similarly, in an isosceles trapezium, the non-parallel sides, here you can see which are the non-parallel sides? AD and BC. In isosceles trapezium, the non-parallel sides are equal. You have one pair of parallel sides and the other non-parallel sides are always equal. So then we call it as isosceles trapezium. Next is kite. We know how does a kite look, right? If two pairs of adjacent sides, so let me just name this. This is a kite. Two pairs of adjacent. Adjacent is basically side by side, having the same vertex. Same vertex. Now see, these are the two adjacent sides which are equal in a quadrilateral, then it is known as a kite. So this side equal to this side. So see, AB is equal to, okay, here there is a printing mistake. AB is equal to AD and DC is equal to BC. So we can clearly see these two sides are equal and these two sides are equal. Correct? Now let us see about the properties, the diagonal properties. The two diagonals are perpendicular to each other. What is a diagonal? Diagonal is basically when two opposite vertex are joined. So let me join. This is one diagonal and this is another diagonal. It is given diagonals are perpendicular to each other. That means this is 90. All these are perpendicular to each other. One of the diagonal bisects the other one. What do you mean by this? One of the diagonal bisects the other one. That means out of these two diagonal, one diagonal is being bisected. So this side is equal to this side. So let me write this. DO is equal to BO. Bisects means it is divided into two equal parts. So let us revise again. In a kite, only the adjacent sides are equal. Adjacent sides means side by side, which share the same vertex. And the diagonals are perpendicular to each other and only one diagonal is being bisected. Next, moving on, parallelogram. Parallelogram, the name itself suggests you have parallel lines. All the opposite sides are parallel. Okay, so we have two pairs of parallel sides. Then it becomes a parallelogram. Okay, so AC is parallel to BD, AB is parallel to CD. Now, next properties here we are going to see opposite sides. In a parallelogram, opposite sides are AB, okay, AB and DC. Opposite. Adjacent means side by side, whereas opposite means they are opposite to each other. So AB and DC are opposite to each other. Similarly, AD and BC are opposite to each other. In a parallelogram, all opposite sides are parallel. all opposite sides are equal. Similarly, all opposite angles are also equal. So A is equal to C and B is equal to D. I hope you understood what are opposite sides and angles. So A and B are adjacent sides because they are adjacent angles. I'm sorry, because they are on the same side, they are situated together, whereas A and C are opposite to each other. Now moving on, adjacent sides. Here I'll talk about adjacent sides. Adjacent sides, as I told you, they both share a common vertex. So what are adjacent sides? AB and BC. So see, AB and BC are adjacent. They are sharing a common vertex B. Similarly, BC and DC are adjacent. BC and DC are adjacent. They are again sharing a common vertex. So all these are adjacent. See, these are all adjacents we see, which share a common vertex and they are situated side by side. Similarly, what are adjacent angles which are again side by side? A and B are adjacent angles. Similarly, B and C are adjacent. C and D are adjacent and D and A are adjacent. These are all adjacent angles. So I hope you're clear with opposites and adjacent. Opposite means which do not have a common vertex, these are opposite, whereas adjacent means which have a common vertex. Here this is a common vertex. Right, now let us see the properties of parallelogram. Very important. So let me draw a parallelogram. This is a parallelogram ABCD. So opposite sides of a parallelogram will always be equal. So DC is equal to AB, DA is equal to BC. Opposite angles are also equal. B equal to D and angle A equal to angle C. Next, the two diagonals of a parallelogram bisect each other. Most of the students get confused here. So first, what is a diagonal? Diagonal is where two opposite vertex meet, two opposite vertices meet. So A and C are opposite. So when you join them, a diagonal is formed. Similarly, B and D are opposite. Join them, a diagonal is formed. Now, what is the property? Diagonals bisect each other. That means AO is equal to OC and BO is equal to OD. Bisect each other means the diagonals are divided into two equal halves. Now, the pair of adjacent angles in a parallelogram will always be supplementary angle. So here what are adjacent angles? We just saw B and C. Angle B and angle C are adjacent. Angle C and angle D are adjacent. Angle D and angle A are adjacent. And angle A and angle B are adjacent. All these are adjacent. What is there? They are always supplementary. That means their sum is always equal to 180 degrees. I hope this is clear. They are always supplementary. So these are the properties of parallelogram. Very important. Now next up we have is rhombus. This is a rhombus ABCD where all the sides are equal. AB is equal to BC equal to CD is equal to DA. In rhombus, all the sides are equal. Now, what are the properties? Let me name A, B, C, D. So you can see that rhombus is also a parallelogram. You can clearly see it looks like a parallelogram. We'll see. So in rhombus, all the sides are equal firstly. Adjacent angles are supplementary. Here, adjacent angles are supplementary, which means the opposite lines are parallel in a rhombus. Very important. So, angle D plus angle C is equal to 180 degrees. Angle C plus angle B is equal to 180 degrees. Similarly, A plus D is 180 and A plus B is 180 degrees. They are supplementary. Now, the opposite sides are equal and parallel. We have already seen opposite sides are equal and parallel. In fact, all the sides are equal in a rhombus. In rhombus, diagonals bisect each other at right angles. Again, what is a diagonal? Where the two opposite vertices are joined, then a diagonal is formed. So these two diagonals are meeting at a point, and the diagonals are always perpendicular to each other. So this is diagonal 1 and this is diagonal 2. Very important, diagonals are not equal in rhombus. Both the diagonals are different. But last fifth point is very important. The diagonals of a rhombus bisect the interior angles. So these diagonals bisect the interior angles means this angle equal to this angle equal to this angle. Now for example, if this total is 100, each angle is going to be 50. Also, in rhombus, I missed a point that the diagonals bisect each other at right angles, and also the diagonals are divided into two parts. So basically, BO is equal to DO and CO is equal to AO. For example, if AC is 14 centimeter, so each is going to be 7 because they are bisecting. They are bisected equally. I hope this is clear about the rhombus. Next up we have a rectangle. A parallelogram with equal angles and equal opposite sides is called rectangle. Equal angles. So here first thing in a rectangle is opposite sides are equal. AB is equal to CD and AC is equal to BD. Also all the angles in a rectangle is equal to 90 degrees. They are all equal to each other. Now let us see some properties of it. Opposite sides are parallel and equal. So these are all parallel and equal as well. Opposite sides are equal. So let us name A, B, C, D. Next, opposite angles are equal. In fact, all the angles are equal because all the angles are equal to 90 degrees. Adjacent angles make a pair of supplementary angles. So here you can see B plus C is 180, B plus A is 180, A plus D is 180, D plus C is 180. Ultimately, when the lines are parallel, adjacent angles will always be supplementary because of co-interior angles. Now, diagonals are of equal length. Diagonals are of equal length. Diagonals are of equal length. Very important. So AC is one diagonal and BD is another diagonal. So they both are of equal length. They both are equal. Diagonals bisect each other. Diagonals bisect each other, which means AO is equal to OC. This side is equal to this side. Also DO is equal to BO. DO is equal to BO. And apart from this, all the diagonals bisect each other at 90 degrees. I hope these properties are clear. So very important is you need to know the properties about the sides, the angles and the diagonals. That is it. You just have these three elements to know about. Now next up we have is last quadrilateral, which is a square. A rectangle with all four equal sides. So a rectangle becomes a square if you prove that all the four sides are equal. AB equal to BD equal to CD equal to AC. Now what are the properties of it? All four sides are equal. Okay, let me just label this square ABCD. All the four sides are equal. AB equal to BC equal to CD equal to DA. Opposite sides are parallel. As we know, rectangle, a square is also a parallelogram. Opposite sides are parallel. Diagonals are of equal length. That means AC and BD are equal. Okay, AC is equal to BD. And diagonals are perpendicular bisectors to each other. They are perpendicular as well as they are bisectors also. That means the diagonals are bisected. They are divided into two equal parts. So BO is equal to DO and AO is equal to OC. This is about the diagonal properties. Same like the rectangle. Diagonals are of equal length, but in rectangles diagonals are not of equal length. In rectangles, diagonals bisect each other at 90 degrees and are bisected as well. Same with square, diagonals are perpendicular bisectors. All the four angles are 90. Same like rectangle, all angles measure up to 90 degrees. So this is about all the properties of the quadrilateral, all the kinds of quadrilaterals we had seen and their properties, which are very, very important. In short, I'll just tell you about diagonal properties because I'm sure everyone knows about the sides and angles in each kind, but everyone gets confused in diagonal when coming to diagonals. So let me just take you through the diagonals. In parallelogram, diagonals bisect, which means this side equal to this side and this side equal to this side. In rectangle, diagonals are equal and they bisect. Okay, in rectangle, the diagonals are equal. So that means AC and BD are equal. At the same time, the diagonals are bisected as well. AO equal to OC, BO equal to BO. Next, in the square, see, square is a special kind of quadrilateral. It has all the properties in it. See, the diagonals are equal, the diagonals are bisected, as well as the diagonals are perpendicular. All of them are equal to 90 degrees. So square is a special kind of quadrilateral because it has all of it. Whereas in rhombus, the diagonals bisect at right angles. They bisect as well as they are perpendicular. Bisect means this side equal to this side and this side equal to this side. So this is all about special kinds of quadrilateral. Most of the questions you are going to have from this or the polygons. You just have two major topics in this whole chapter. So I hope this introduction part is clear. Since for once you see this video, your introduction part will be clear, and in my next video I'm going to share some important questions which will be easier for you to do only if you watch this whole video. So see you in the next video. I hope it helped you. Please subscribe for more such content. Thank you.